Ayo, ayo. So in this question, we have been asked to draw an ER diagram and then convert that ER diagram into a relational model for a hospital with a set of patients and set of doctors. We need to associate each patient with a log of the various tests and examinations that are conducted. Okay, so let's get started. By default, as you can see, we need patients, we need doctors, and we need the logs. Okay, like logs for the various tests that are conducted. So we could call this test logs, I guess. Yeah, so we identified three entities. Okay, so let's jot them down. Firstly, we'll have a patient, then we'll have a doctor, then we'll be having the test log, for example. Okay, so now the patient will have the patient card details, no? Like there's the name, age, then whatever illness the person has, ailment basically. Then perhaps the patient could have his own ID, no? So let's call it patient ID. Okay, then what else would the patient have? Gender, and I guess we can also add name, age, ailment, gender, PID, patient, na? I guess we'll also need contact details, na? So we can add a phone number, for example. Now similarly for a doctor over here, we'll have our doctor ID to uniquely identify the doctor. Then we'll have, what do you say, the doctor ka name. We can also have the specialty, like whether the, what do you say, specialty, like whether the doctor is a cardiologist or something. वैसे. Then we have, let's say, the contact details, so phone number and perhaps an email as well. Since this is our database, we can either make this multi-valued or single valued. Okay, I just wanted to make things simple, so I kept everything single valued. But if you want, let's keep one variable as multi-valued. Okay, multi-valued means a doctor can have multiple email addresses, but however a doctor can only have one phone number. Okay, so now let's move on to our test log. Okay, this much is enough for the doctor. The test log will have its own, well, a test log can only exist if the patient is there, no? So we can make this a weak entity that is dependent on our patient. Okay, so our patient can, what do you say, patient has test log. Okay, and since this is a weak entity, this will be a double diamond. Okay, now a patient, क्या बोलते हैं, a patient can have a test log or cannot have a test log, na? So we'll have a single line here, but however if a test log is there, then it must have a patient associated with the test log itself, no? So that's why we'll have a double line here. Okay, and now one patient can have any number of tests, no? Like perhaps the doctor said to do a blood test, then he told to do a stress test or something. So one patient, this is a single line. Okay, so one patient can have n number of tests. So that's why we made this relation. Also now, what do you say, the test log mein we can put the, what do you say, test name. So we could just write name of the test, then perhaps the cost of the test, and whether the test was basically like the test ka details. So test details, for example. Okay, and Yeah, I guess should be good only. And now each patient is treated by a doctor, no? So will each patient is, what do you say, treated. Each patient is treated by a doctor. Now a doctor, uh, the doctor may be present or absent, and the patient also may be present or absent. It doesn't matter, no? Both are independent of each other. Even if the doctor wasn't there, the patient would exist, and even if the patient was there, the doctor would exist. Which is why we have single lines here, okay, to indicate partial participation. Single line means partial participation, double line means total participation. Total participation means that this entity is completely dependent on the other, but partial participation means this entity is not completely dependent on this one. A patient can exist without a test log also. वैसे. Now we have how many patients? We could have, like, let's say one patient who is treated by n doctors, no? But what do you say? One doctor can treat many patients. It's not like this doctor has to treat one patient only. So this is n is to m type of relationship where one patient can be treated by many doctors. वैसे. So I guess this is the ER diagram. Now let's look at the schema. Okay. So now for the schema, we need to make a relational schema, no? So now relational schema. And if you want, you can write over here. This is the ER diagram for a hospital. Now we will be converting this ER diagram into its relational schema, basically in the form of tables, okay? So firstly, let's have a look at the entities. We have one entity, two entity, three entities, no? So at the very least, we'll have three tables. One will be the patient table, and then we'll have the doctor table, and then we'll have the what do you say, test log. The test log is a weak entity, okay? Test log. Now in the patient table, what all information do we need? We need the name of the patient, then the patient ID, the age, gender, ailment, and phone number, no? So we can just jot that down. In the patient table, we'll have the patient ID, the name of the patient, age of the patient, the ailment of the patient, gender, and phone number. See, 1 2 3 4 5 6. 1 2 3 4 5 6. Yeah, okay. That's the patient correlation done. Now if you look at the doctor correlation, we'll have all the doctor ka stuff. No, we'll have the doctor ID, name, specialty, phone number. We won't have email, okay, because email is a multi-valued attribute. No, so we'll have to make a separate table for that. So here we'll have doctor ID, name, specialty, name, specialty, phone number. Yeah, okay, that's done. So like the table could be drawn like this. Now if you look at our test log, okay, our test log is a weak entity, right? So our test log is a weak entity and it is dependent on our patient, no? So in order to uniquely associate our test log with our patient, we will be needing the primary key of the patient, okay? Since this is, oh yeah, I forgot to underline. This is the primary key of our patient table and this is the primary key of our doctor wala, matlab, entity, okay? Entity, yeah. So basically the primary key must be underlined like this, okay? And if there's any partial key, we can just put a dash to it. Since over here test log doesn't have any partial key, we could give it one if we want to by saying test number, okay, and the partial key is underlined with a dotted line. Okay, so now in our test log, we'll have the primary key of this entity, patient entity, along with its own partial key. The partial key is test number, no? So test number. Now we'll have the other remaining attributes as it is, that is name, cost, and details. So we made this table also, and as you can see in test log, we are referencing the PID from the patient table, no? So we must make an arrow that points to this very attribute, वैसे. So I should show that there's a relation from here to here. Okay. Now, as you can see, there's a relation between the patient and a doctor as well, no? With the treated relation, basically. So for that, we'll need to make another table or relation, and that could be called this thing treated, no? So treated, and it's between our patient and the doctor, right? So we'll have our PID and doc ID. Basically, both the tables ka primary keys can be used, and also underline all the primary keys used. Okay, underline here, underline here. These should be underlined. You can underline these also. Yep. And since we are referencing this from PID wala table, we need to show that we are doing so by just using an arrow. And we are referencing doc ID from our doctor table, so we can show that as well with another simple arrow. Okay. Yeah, but we are not done yet. Okay. We still have, we finished patient ka all the details. We have this relation here because PID 1 is to n, no? So we put the PID in test log, as you can see. PID over here in test log. Now, what else? We finished this relation over here, finished making a table for it, that is situated between patient and doctor. Okay. So each patient is related uniquely with the doctor. And now lastly, we just have this multi-valued attribute called email left, no? So now the email is basically the doctor ka email, right? So we, for the email relation, we need two attributes. One is the doctor ID, which will be the primary key, and then we need the email of the doctor. In this way, we'll be able to uniquely identify the email of the doctor. And since we are referencing the doctor ID, we need to draw an arrow to the table from which we are referencing it from. So now this arrow will go. I could have drawn it from the other end also, but it was already a bit messy there. So I thought I'll go around and draw this. Okay. So I guess this is our relational schema basically for this ER diagram. I made it in rough a bit, but I guess you get the point. Okay. So if you get such a question in the exam, this is how you're meant to solve it. Firstly, you can, if you want, you can rewrite the problem statement, but no need for that. You can just directly start drawing the ER diagram in such a fashion. Just in rough, first plan out the entities, okay? Like there's patient entity, doctor entity, and there'll be a test log or log entity over here, no? So three entities, and based on those three entities, you can expand their attributes and stuff and their relations, like treated relation. And since this one was a weak entity, we used a double diamond. Okay, this is your identifying relationship. Okay, and this is our multi-valued attribute over here. And also don't forget the cardinalities. That is 1 is to n, n is to m. There's one. It could be 1 is to 1 also. Depends on what ER diagram you're making. Okay. And similarly, we converted it into our relational schema step by step. Relational schema for our hospital ER diagram. Nice, sir.